Hello, here's another AQA A-level question on the particles topic. If you want to try and answer this question yourself, pause the video now. If you got the answer right, well done. Okay, so the diagram represents a particle interaction. There's the diagram, often called a Feynman diagram. Which row identifies particles E, F and G? Okay, so this is a beta plus decay reaction, and it's one of the reactions that you have to learn. And that reaction is a proton decays into a neutron plus a beta plus particle, otherwise known as a positron or an anti-electron, plus an electron neutrino. So we can immediately see that G must be this electron neutrino. However, let's say we don't fully remember this particle interaction. We could work out what this particle is here. We know that lepton number must be conserved. And we also know that a proton is a baryon, so it has a lepton number of 0. A neutron is also a baryon, so lepton number is 0. The beta plus particle is an anti-electron, so it has a lepton number of -1. So whatever this particle is going to be here, it must have a lepton number of +1. Well, if you look on your data sheets, you'll see there isn't much choice of what particles can have a lepton number of +1, but neutrinos are one of them. So on the left-hand side of the equation, the lepton number is 0, and on the right-hand side of the equation, the total lepton number is 0. So lepton number has been conserved. Particle G is a neutrino. Okay, so this interaction shows a proton decaying into a neutron, but if we look at the table here, there aren't protons, neutrons, there's quarks, up and down quarks. So we need to now consider what protons and neutrons are made of. Again, it's quite a handy thing to know that a proton is made of 2 ups and 1 down quark. But let's say we couldn't remember that. If you look on your table in your data sheet, you'll see that an up quark has a charge of +2/3 and a down quark of -1/3. If we add those together, we're going to get a charge of +1. Let's put Q here to remind us that we're talking about charge. So a proton has to be made of an up and down if you're going to get this charge of +1 and a proton and a baryon number of +1. Again, we could do the same with a neutron. It's handy to remember that it's up, down, down, but we can prove that it's up, down, perhaps if you've forgotten. +2/3 charge for the up quark, -1/3 for each of the down quarks. Add those all together, we get a charge of 0, and of course a neutron has a 0 charge. So we can see for a proton to change into a neutron, or to decay into a neutron, an up quark must decay into a down quark. So we can see that E must be this up quark and F must be the down. So E is an up quark and F is a down quark. Answer is A. If you found this video, click on that subscribe button please, share with your friends and watch more in the series. Thank you.